Okay, here's that last problem. Hopefully you can see this. This was an N-channel FET with a 1K ohm here and a 2K ohm here going up to 10 volts. Get the light a little better. Okay, so that was 2K ohms, that's 1K ohms. This was down to ground, and we had a 14 on that side, K, and a 6 on that side. You can see the arrowhead, that's the source. And this also went up to that 10K. Alright, and so it said what's the gate to source voltage, what's the drain current, and what's the VDS. Alright, we're going to start this one. We don't know any of those things so far, and what we're going to do is say the easiest thing to figure that out is going to be to figure out the gate voltage at this point. So I want to have a look at that and figure out what's going on there. Now I know there's no current, current into the gate is 0, so therefore all the current that flows through this 14K ohms flows through this 6K ohms. So that's just a resistor divider. You can think about it as, okay, that's an equivalent of 20K ohms, 14 plus 6 is 20. So I, through those resistors over there, is 10 volts over 20K ohms equals 0.5 milliamps, which we don't really need to know that, but if it helps you to see what's going on, and I got a half a milliamp going down this left side, and a half a milliamp times 6K ohms is going to give me 0. Voltage at the gate equals 0 plus, where am I starting, plus I times 6K, and that's that IR for the resistors, and that's 0.5 times 6, half times 6 is 3, so I end up with 3 volts. Alright, so I now know that the voltage on the gate is 3 volts. I do not know what gate to source is because the source is not tied to ground directly, it goes through a 1K ohm resistor. I do know that the voltage on the source equals 0 volts plus I sub D, which I don't know yet, times a 1K ohm. And that's good to know, but I don't know this yet, so I don't know VGS. I don't know VGS yet. I only know the voltage on the gate, and as I wrote on several test papers, voltage on the gate does not equal the voltage on the gate to source. Okay, so I got to keep going. I've got 3 volts here. I've got ground down here, and what I'm wondering is, first thing is to check and see, is this transistor on? There's certainly 3 volts on the gate. If it's not on, devil's advocate, if it's not on, then there's no current flowing through there. If there's no current flowing through there, then the voltage across this 1K ohm is 0. So if the voltage across the 1K ohm is 0, then if that were true, I'd have 0 volts here and I'd have 3 volts there. And since VTN, the threshold voltage for this problem, is 1 volt, if you took it with the main group, then you get VTN equals 1 volt, and gee, I've got 3 volts here. If it were off, I'd have 0 volts here, so I'd have 3 volts from gate to source, and that is in conflict because certainly that's more than VTN, so it's above the threshold, so I know it's not off. I don't know if it's in saturation or if it's in triode, but because the equation's easier, I'm going to assume, by the way, I said state your assumptions, not everybody did. Assume saturation, so that says that ID equals, by the way, notice I'm trying to use the capital letters. The other part that was given, case of N equals 2 milliamps per volt squared. Alright, so ID equals, this is my equation for that. If it is saturated, VGS minus VTN squared. And I'm going to use, and it helps me to, I always do this, I want to remember I'm going to use K ohms, milliamps, and volts. And I'm going to say, okay, remember that. So I'm going to write this as 2, and that's in milliamps per volt squared, times VGS. And I don't know what VGS is, but I know it's 3 volts minus ID times 1K. So watch carefully. What I'm going to have is 3 volts minus ID times 1K, but I'm going to drop the units of K ohms. So that's my VGS. VGS equals 3 minus ID times 1K ohm. 3 volts minus 1 ID times 1K ohm. And if I do drop all the units, and remember I've got them someplace, then I get 3 minus ID. I've got to then subtract the minus VTN. Well, VTN is 1 minus 1 squared. So here's my equation, assuming it's in saturation, that ID equals twice 3 minus ID, which is VGS, minus 1, which is VTN, squared. All right. I saw a couple people then take this and very complicatedly draw all that out, but hey, look what's going on. I've got 2 times 3 minus ID minus 1 is 2 minus ID squared. And that's ID. And that's equal to 2 times 4. 2 times 2 is 4, minus 2ID minus 2ID is minus 4ID plus ID squared. Yeah, I need to keep that parentheses because that 2 is the KN is out in front still. Okay, so keep going with that. And what do I get? So ID equals 2 times 4 is 8. 2 times minus 4 is minus 8. ID. And 2 times that is plus 2ID squared. Or am I going to rearrange this and put it into my easy quadratic form? I'm going to have 2ID squared. That's my only unknown at this point, right? So 2ID squared minus 8ID. Oh, wait. I got to subtract minus ID from both sides. Let's make that a 9. Why? Because there's an ID on that side. I'm going to subtract an ID from both sides. So I'll end up with minus 9 ID, and then that's a plus 8 equals 0. Okay, so then quadratic formula says ID equals negative B. Well, B is minus 9, so 9 plus or minus the square root of B squared, which is 81 minus 4 AC. A is 2 times 8 all over 2A. 2A is 4. So that's, what the heck is this? I'm going to run out of paper. 9 over 4 is 2.25. 2 1/4. 81. 4 times 2 is 8. Oh, it's 81 minus 64. 81 minus 64. 81 is 17? Yeah. Plus or minus the square root of 17 over 4. Okay. You can rewind the tape. Okay, so ID equals 2.25 plus or minus square root of 17 over 4 equals, calculator, 17 square root of divided by 4 equals 2.25 plus or minus 1.03 equals change sign plus 2.25 equals 1.29, excuse me, 1.219, or 2.25 plus 1.03 equals 3.28. Now I'll do something I should have done before, which is draw the load line. What's the most voltage that would ever be across this thing? If there's no current flowing, then there's no drop across that, and there's no drop across that. So if there was no current flowing, then I'd have 10 volts across that transistor. The lines always look like that. V, D, S, I, D. Why am I doing this? Because I want to figure out, without going through everything, I should have done this before, but which of those answers makes the most sense for ID. Okay, so anyway, the most voltage that could be across there is 10 volts. The most current, I got 10 volts up there, I got 0 down there, and I've got, if this were dead short, and what do we call it, dead short, if this were short circuited, I'd have 3 k ohms in between. 10 divided by 3 is 3.33 milliamps. Okay, so one of those answers is at 1.29, which is like here-ish. Maybe a little bit higher, whatever, it's down along there. 1.29, and the other answer is 3.28, which is, wow, that's really close to there. So, looking at this, the smart money says, you know, that is probably in the triode region and is not going to be a good thing. We can go back and check that later, but, you know, I like this 1.29 answer. So if I look at that first, let's just check it out. If I've got 1.29 volt, 8 milliamps going through here, well, I got 1.29 milliamps going through a 1 k ohm resistor. That would make this 1.29 volts at Vs. So if this is true, then Vs equals 1.29 volts. And if that's true, then VGS equals 3 minus 1.29 is 1.71. 3 minus, it's read my own writing, 1.29. Yeah, okay, so 1.71 volts. So that's more or less, I say that would be the volt VGS. Slightly different answer. Oh, that's why it's 1.1. I'm sorry, that's 1.19. Remember, I've got that 1 in there, so it's not. It's 1 point. So it wouldn't be 1 point. It would be 1.19 volts. Sorry. So carry that mistake through. 1.219 instead of 1.29. 1.219 volts. 1.219 is 1.78. 1.219. Okay, so VGS is 1.78 volts. Okay, therefore, how much channel do we have, or what's the saturation? You know, how do you tell if it's saturated or not? You take 1.78 volts and compare it to minus VTN. So if that's VGS, then minus VTN, VTN is 1 volt. So that says how much channel I've got is VGS minus VTN equals therefore 0.78. So now I've still got to check, am I saturated? I'm saturated if I've got more than 0.78 volts across there. And do I? Well, okay, I've got 1.22, 1.219, whatever milliamps going through there. So I know I've got, or I think I've got 1.219 volts there. What do I have here? I have 10 volts minus twice 1.219. So 1.219 times 2 equals 2.38. 2.438 change sign plus 10 equals 7.562. And I'm using ink, so I hope this is right. I know it is. So that says on the north side of that, north side being the drain, I've got 7.562 On the south side, south for S for source, 1.219 volts. So the difference there is 6.3, something like that, which is certainly more than, since VDS is around 6.3 something volts. That is certainly more than 0.78. So my saturation sounds like a good thing. Actual answers that I got were 1.78. Yeah, 1.78, 1.22, 1.219 is what I wrote here, but 1.22, and 6.34, 6.3. Okay, so that's that thing.